In the silence of deep space, a message has arrived. It's not a transmission, not a beacon, but a traveler. The James Webb Space Telescope has caught sight of something vast, only 10 light-years away, and on a path that bends inward toward our star. What the telescope found is not a comet in the usual sense, not the kind of dusty snowball we sketch in school books, but a renegade that rewrites the rules. It has been given a name, 3I Atlas. Formally catalogued as an interstellar comet, yet in truth it is a category of its own, something stranger than the word comet was ever meant to contain. Its light betrays secrets. When Webb's near-infrared spectrograph turned toward it, the spectrum spoke in a language no one expected. Carbon dioxide roared through the data, while water, the classic voice of comets, whispered only faintly. The balance was inverted. Instead of a water-led outgassing, carbon dioxide dominated the show, creating a coma where Co outshines every other volatile in its geometry, disturbing in its refusal to conform. The glow stretches sunward, as though the plume itself prefers the warmth, breaking the centuries-old image of tails fleeing into the dark. The plume is dense, compact, a curtain of grains thrust forward rather than swept back. A faint antisolar tail follows behind, but the primary plume defies expectation. This is not the easy story of ice melting under sunlight. This is a revelation that forces scientists to re-examine what interstellar visitors truly are. Why does it behave this way? One possibility is that cosmic radiation has carved away its surface over eons of drifting in interstellar space, leaving carbon dioxide preserved near its skin, while water retreated deeper down, muted and dormant. Another possibility is that it was born near the CO ice line of its original star-S protoplanetary disk, a place where carbon dioxide froze efficiently while water followed a different pattern of retention. Either way, it formed far outside the comfort zone of our own solar system SRERT, cloud or Kuiper belt archetypes. This makes 3I Atlas more than just a traveler. It is a time capsule. It carries the fingerprints of another system's birth conditions, offering us a rare chance to study the chemistry of worlds that orbit other suns. Its activity is more than chemistry, it is dynamics. Outgassing in one direction creates torque. The plume's asymmetry means that as gas erupts, it could alter the spin of the nucleus, twist its orientation, even nudge its trajectory ever so slightly. These subtle forces matter because they let scientists reverse engineer the hidden structure of its core, learning whether it is a fragile rubble pile or a more solid fractured remnant. The strangeness of Atlas recalls its predecessors. Oumuamua was the first, a silent shard that barely revealed its chemistry at all, leaving only speculation in its wake. Borisov was the second, a more familiar-looking comet with recognizable molecules: water, carbon monoxide, cyanide comfortingly similar to local comets. But Atlas is the third, and it is the disruptor. CO is its leader, water plays second fiddle, and its plume geometry scoffs at tradition. 3 case studies, 3 very different personalities. The word comet now stretches until it nearly breaks, yet with this strangeness comes profound opportunity. Every molecule measured becomes a bead on a string connecting planetary disks across the galaxy. Every grain of dust lofted sunward is a clue to the material strength and thermal inertia of a world born under another star. And this diversity carries consequences. Imagine young planets in a distant system, bombarded not by water-rich comets like those that seeded Earth, but by carbon dioxide couriers like Atlas. Such deliveries would alter climates, tilt atmospheres toward greenhouse regimes, and shape the chemistry of oceans and rocks in ways utterly alien to Earth's history. This is not just planetary science. It is astrochemistry, astrobiology, and cosmic ecology combined. Interstellar comets are not rare accidents. They may be constant messengers, fragments from star systems shedding their leftovers into the galactic sea. Over time, these fragments crisscross the stars, carrying volatile cargoes, sometimes even the building blocks of life. Atlas is not dangerous. Its path never comes near Earth, but it is urgent. It will pass through the inner solar system once, and only once. Then it will be gone forever, cast back into the abyss, unbound from our gravity. Everything we learn must be learned now. For scientists, That urgency has forged a global response. The James Webb Space Telescope caught the decisive spectrum. Hubble and Earth-based observatories are tracing its evolving plume. A portrait of an alien worldlet is being drawn in real time as it races toward its October perihelion. And what does that portrait show? Body unapologetically different? It tells us that diversity is the default of the cosmos. That water-driven comets are not the rule, only one chapter of a much larger book. That our categories must stretch, or else they will shatter. Atlas is a reminder that science thrives when definitions dissolve. It challenges us to stop clinging to old templates and instead ask, what energy drives its activity? Which molecules dominate momentum transfer? How do grains evolve as they scatter light in real time? This is not the familiar picture of a dusty snowball trailing obediently away from the sun. This is something Wildra, sun-facing plume powered by CO, colored by strange scattering, textured by the fingerprints of another star's birth. It is, in every sense, a messenger, a fragment of another system, courier of carbon, a sample of chemistry written far beyond the boundaries of our sky. Atlas has crossed into our solar system only to leave again. But in its brief passage, it leaves behind something greater than dust or gas. It leaves questions. And with them, the chance to rewrite our understanding of how worlds form, evolve, and scatter their fragments into the galaxy. The cosmos is not small enough for our old categories, and Atlas is the proof. It begins with a plume of carbon dioxide, but what it really unleashes is a revolution of thought. Astronomers gathered around the spectrum as though it were a coded message, each spike and dip in the graph whispering secrets from another star system. For centuries, comets were defined by water. They were seen as dirty snowballs, repositories of frozen oceans drifting through the solar system, melting into tails of vapor and dust when the sun warmed them. But Atlas dares to tell a different story. Here, carbon dioxide takes the throne. It is not secondary, not a faint echoit is the driver, the prime mover, the breath of this interstellar fragment. This alone forces a rethinking of how we categorize. Comets are not only water couriers, but also carbon couriers. Then the very chemistry of young worlds can tilt in directions Earth never experienced. Imagine a young planet not showered by water-heavy bodies, but by swarms of CO-laden messengers like Atlas. Its atmosphere would be thick with greenhouse gases from the start. Its oceans acidic, its climate less forgiving. Life, if it emerged, would crawl into existence through pathways utterly unlike Earth's. The implications ripple outward. When astronomers look at exoplanets, those pale shadows revealed as they transit their stars, they see spectral fingerprints of gases. They search for oxygen, methane, water vapor. They dream of biosignatures. But what if the starting conditions of those worlds were written not by water-bearing comets, but by carbon couriers? What if their skies, their seas, their rocks were tuned to a different chemical symphony from the beginning? Atlas whispers that question with every plume it releases.